Assalamualaikum warahmatullahi wabarakatuh and very good day to everyone. My name is Muhammad Lukman Azim bin Muhammad Ayub. I will be represent the Group 3 for the Industrial Power System project using the ETAP simulation. So first of all, I will introduce for all my fellow group member. Our team leader is Ahmad Solihin bin Azlan, and then Hazwan Azraf, Muhammad Hazwan Azraf bin Muhammad Azman, and Joshua Isaac Feeling, and last but not least is Nur Sabrina binti Roslan. So it's provided is an appendix A, which including the single line diagram of a simple industrial network. So based on that single line diagram, we have to construct the industrial network step by step lah, using ETAP. We have to install the network feeder, and then some of the current transformer. Also there is a relay and also utility bus lah at the top of it. For this video, I have cut some of the step as there is a repetition step, or to make it less time consuming. After we already finish all the network in the utility bus, we going through to the switchgear bus, which is have 4 bus bar. So the first bus bar is fuse switchgear, and the other 3 is circuit breaker switchgear, which have induction motor load. Fuse switchgear, there is a transformer number 2 with the value of 350 kilovar and MV bus. So under the MV bus, there is 3 bus bar, which is circuit breaker MV1, and then another 2 is fuse lock and fuse lump. Beside that, the component under the MV bus, we have the circuit breaker MV1, fuse lock 1 and fuse lump 1. And for the first bus bar, there is induction motor, and then for the fuse lock, there is a static load, and the last one, we have the lump load for the last bus bar lah, that have the fuse lump. So that's all for constructing the simple industrial network using the ETAP. We have to install the network feeder, and then some of the current transformer.
Assalamualaikum, my name is Ahmad Solihin. So I will present on how to insert the value for each component based on the Excel data that are given. So let's say first we want to insert the value for bus. Just click at any bus, and then if we want to insert the value for the nominal voltage, just go at the bus editor and then click on info tab, then just change the value for nominal kV. Okay, done for bus. Next we go to cable. Let's say for cable 1, just click at cable 1 component, and then we need to choose the type based on the given type in this Excel. So we need to click the library button here, and then we can choose what type that we want to use. Next is for transformer. Let's say for transformer TX1, you can go to the 2 winding transformer editor, and then let's say the core type is shell. You can choose here shell, and then the primary to secondary rated power is 1 kV and 1 mega MVA. Go to the rating, then we can change here 1 MVA. Then for max transformer rating, you can go to the here alert max. You can choose, and we can change the value here. Okay, done for transformer. Next for induction motor, just click at induction motor, then here we can edit all the value. Then proceed to the static load. Static load component is here. This is the editor for static load. Then next is lump load, low voltage circuit breaker, high voltage circuit breaker, fuse, current transformer, utility, and universal relay. Basically all of the component use the same way to change the value. So just click at the component and then you can change the parameter. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazwan Azraf bin Muhammad Azman. My metric number is AE20025. Now we move to the load flow steps, which is this pencil symbols is for the edit mode setting and the PQ symbol is for the load flow mode settings. And this is our whole industrial power network circuit. And we have insert all the values for the transformers, circuit breakers and cables. And then we run the simulations and we can see that the utility bus have the percentage voltage is 100%. For the SWGRA is 82.43% for the percentage voltage, and the MV bus is also 77.92%. This 3% is for voltage percentage, and this is our original circuits without we didn't improve any improvement. And for the improvement part, we select and apply the capacitor bank, and then we change the value for the capacitor bank from 0 to 1.35, and then we click OK. So this is our improvement, and we click the load flow settings and we run the simulations, and we can see the result is for the utility bus the percentage voltage is still the same, but for the SWGRA the percentage voltage increased from the 82.43% to 99.41%, and for the MV bus is also increased with 95.27%. From modified, before modified, we have 72.92%. So we can see that the percentage voltage is increased. And another features for the ETAP software is we click the alert view and we can see the upper table is for the critical conditions, which is the red line, and for the lower table is for the marginal line, which is the color is pink or purple. So that's all from me. Thank you and Assalamualaikum.
Hello and have a good day, doctor. So my name is Joshua Isaac Felix. My number matrix AE210044. So before this, my friend already brief about the simulation and about the flow. So now I will present about the short circuit. So firstly we will go to the short circuit term. So after that we go to the three-phase fault. Okay, so from here we can see that they have three short circuit, which is from utility bus, SWGRA and MV bus. So firstly is from the utility bus 11 kV is have the 5.43 k ampere. So this is the fault current for the utility bus. So second is the SWGRA, which is have the largest and the highest fault current. This is because the fault current from at the SWG is not only contribute from the upstream utility bus via the network feeder and transformer, but also from the downstream, which is we can see here with in the cable 4, cable 5 and cable 6 is the inductive load, and editing with the capacitance bank here, it's make the short circuit will make the fault current. This is because the from the the motor will be as a generator during a fault or short circuit duration. So next we proceed to the MV bus. So MV bus is the lower from the others fault current, not the addressive, I mean is the SWGRA, is because it's reflect the sum of all downstream contribution reduced by the impedance from transformer 2 and the cables. So it's already reduced by the transformer, so that the NV bus fault current is lower than SWGRA. So next we will go to the graph. So for the graph, we will, for description, we will add all. And for the ID, we only check for the three is NV bus, SWGRA, and the utility bus. So based from here, we can see the all result that get here is same from the report. So we can see that all the green is the SWGRA is the higher than all. It's because that I see that before, because there is the middle of combination from feeder to feeder. So this is the total fault current, the AC component of fault RMS, DC component of fault current, percent DC component of fault current. So the lastly is for the top elevate of fault current. Okay, that's all from short circuit. Thank you.
Assalamualaikum and hi everyone. My name is Nur Sabrina binti Rosnan from Group 3. So I will further continue by do the analysis for the harmonic. So we need to find the button of harmonic, and then after click the button, we need to find the run button to analysis or run the load flow to get the value of distortion. And then after that, we will see that the utility bus have the 4.08 of distortion harmonic, and then for the next bus at the downstream side, which is 0.34 for the SWGRA bus, and the last point is 0.24 at the NV bus. After that, we will see the pattern of the graph. Okay, we will click to see how the graph. We will start the plotting, and yes. Okay, we need to click on sudah. Okay, we need to click on SWGRA, which is the three bus bar that we used before, which is utility, NV, and SGRA bus bar, and we want to see the waveform and spectrum. So we start to plot, and the pattern will be like this. Okay, for the waveform, we do have three bus bar. Orange represent to utility, green represent to SGWRA bus bar, and the last color, which is blue, represent to MV bus bar. Okay, the most highest amplitude were lead by orange line, and but do not have the perfect because it has a lot of noise. And for the green line, which is the SWGRA bus bar, it follows with the slightly lower amplitude but to have a stable and perfect shape of sinusoidal and less distortion. For the blue line, which is MV bus bar, represent the lowest amplitude compared to others with minimal distortion. Okay, we will see the pattern of a spectrum along the rises of frequencies. Okay, for the utility bus, which is orange one, has the highest distortion because it has it is at the point of common coupling where the harmonics accumulate at this point. Also, it has the highest distortion because of it combined with the effect of multiple harmonic source from the source. Okay, for the other bar, which is green and blue, represent 2MV bus bar and SWGRA for the blue green. It has the lower distortion because it has the higher impedance at the lower voltage levels. Also, it has the quite distant or far away from the harmonic source. Yeah, as we can see, the higher level of voltage source, it will tend to have higher distortion. Okay, okay. This pattern of graph is clearly distribute and helps the engineer in design and effective mitigation strategies and protect the equipment from harmonic related to this issue. Thank you.